Hi everyone, this is lesson 3.0, which is a review of equations of lines, and this is part 2. We've already talked about equations of lines in systems of equations where we learned to graph, but after this lesson, you should be able to determine equations of graphs. Of lines using various pieces of info. Okay, so I've actually broken this lesson up into 4 separate parts, and I'm going to go through them in turn. And I've actually decided to begin the lesson with what some might consider to be the most confusing part of this unit. So keep in mind this is all a review of grade 9. I wanted to start with the review of horizontal and vertical lines. So I'm actually going to start, by drawing 2 different lines. Okay, so let's start with this one on the left here. So if I were to draw this line, I think you would all agree that this is a vertical line. Now, if I want to figure out what the equation of this line is, what I could do, one of the ways I can think about figuring out the equation of this line is by looking at various points on the line. So I haven't labeled anything here, but I'm going to start by saying that this point here is 4, 0. Okay, so we know it has an x-intercept at 4, 0. And then one way to think about finding equations of vertical lines is just to take and name several points on the line. So, I don't know, maybe that's 4, 1, and maybe here we've got 4, 2, or 4, 3. And I know this looks a little bit random, but what I want to illustrate here is that regardless of where I pick these points in red on this line, I can see a pattern, and the pattern is the following: that all the points on this line have x value equal to 4. And this is one way of thinking about how to get the equation of the line. So very literally, because every point on this line has x value equal to 4, I can say x equals 4 is the equation of the line. Now, in other words, on a vertical line, all points have the same x-intercepts, x value. Okay, so the equation of the vertical line is always x equals the x-intercept. So whatever this point is here, in this case it's 4, 0, that will be the equation of the line. Let's look at horizontal lines. These ones are a little bit maybe easier to think about, but they have the same idea, to find the equation of the line. So let's say that this is 0, 3. Well, if I were to take any other points on this line, what I might see is this is -4, 3, and this is 2, 3, and this is 5, 3. But the pattern that I'll be seeing here is that for all of them, the y value equals 3. Okay, so in this case, we can see that all the points on this line have the same y value, so the equation of the line is y equals y-intercept. Before we move on, I just want to make a really important statement, and that is with regards to the slopes of these lines. So what I sometimes get told about vertical lines is that they have no slope. And I want us to really be cognizant about never saying this. It's not that they have no slope, it's that their slope is undefined. Meaning that the slope is so steep there isn't a number big enough to actually define it. So another way we kind of symbolize this is using infinity. So the slope is infinite. It's so steep that it doesn't have a number big enough to describe it. Whereas on the other hand, a horizontal line has a slope of 0. So it is literally flat. And this is why I want us to stay away from saying no slope in vertical lines, because technically, I guess a horizontal line has no slope because it has a slope of 0. Okay, it's completely flat. Okay, so now that we've covered this, let's just do a couple of simple questions with vertical and horizontal lines. Determine the equation of the vertical line through -4, -2, so maybe let's graph that. So -4, -2 is here, and if I graph that line, I can see that the equation of that line, because it's going to have x-intercept -4, is x equals -4. Let's look at the next one. So a horizontal line that goes through -5, 6. Okay, if I draw the horizontal line, I can see that the y-intercept is 6. Y equals 6 is the equation of the horizontal line. All right, moving on. So let's talk quickly about slope. And the first thing I want to do is remind us what the equation for slope is. So slope, which is denoted by m, is y2 minus y1 divided by x2 minus x1. Okay, and that's the slope between 2 points A and B given like this. Okay, and also remember, because I get this all the time, it doesn't matter which point you choose as A or B, as long as the y2 and the x2 match up. So they're both the first part of the fraction, or the left-hand side of the fraction, and as long as you line up the y1 and x1, it doesn't matter whether or not you, what order these two appear in. So you can always flip the yellows and oranges, okay, but you can't flip them diagonally. Okay, so let's determine some slopes. Okay, so here we go. All right, guys, so we know that 0 divided by anything is still 0. Okay, so we know the slope between these is 0, and this indicates that it's actually a horizontal line, doesn't it? And if we did actually graph this, we would get -7, 9 and 10, 9, and it would be the horizontal line through y equals 9. Okay, guys, let me stop here and mention a common mistake. A common mistake is that guys tell me that m equals 0 here, and this is not true. The 0 is in the denominator. If I took out a calculator and tried to calculate -3 divided by 0, I would get an error, because here m is undefined. Okay? And yeah, this is a vertical line. How do I know? Well, if I were to just really quickly plot this, 5.16 and 19, I can see that this is just the line x equals 1. This line y equals 9. Okay, so we've done a couple of slope calculations. And what I want to do now is take a look at finding slope when I'm given a line. So remember, this is standard form, and I can't really see what the slope is in this form. But if I translate it into y equals mx plus b form by isolating y, I should be able to see the slope pretty easily. So what I'm going to do is take this line, okay, and I'm going to subtract 3x from both sides and -5. And now I want to divide everything by -6. Okay, 3 over 6x plus 5 over 6. And actually it doesn't really matter because I'm just looking for the slope. But here I can see that the slope is 3/6, or better to write it in its most reduced form, 1/2. Okay, and same deal here. I'm going to isolate y. I'm going to divide everything by 5. And here I get that the slope is -2. All right. Okay, now on to part 3. Part 3 is a review of parallel and perpendicular lines, which again I'm sure you've seen. Parallel lines have the same slope. Okay, and then let's just keep in mind that vertical lines, because they have undefined slopes, okay, they're a bit different. Okay, all vertical lines are parallel to one another. Okay, in perpendicular lines, we have this idea of a negative reciprocal. Okay, keep in mind that I might be using these symbols to indicate parallel and perpendicular slopes or lines. But we know if two lines are perpendicular, their slopes are negative reciprocals, or in other words, their product is 1. You can think about it either way. And this one's important too. All horizontal and vertical lines are perpendicular to each other. So I know a vertical line has an undefined slope, and a horizontal line has a slope of 0. So these two slopes are actually perpendicular to each other. Okay, let's fill in the following table. I've given slopes and I want to write down the perpendicular slope. So for all of these, what I'm going to do is I'm going to write the reciprocal, and then I'm going to change the sign. So these are technically negative reciprocals. And if I were to multiply these across, I would get -6 over 6, which is -1. Okay, so if two slopes are perpendicular, they will multiply to -1. So here we go. I think these are pretty easy, and this would be positive. I don't actually have to write that down though. So if I have a whole number 10, I can think of it as 10 over 1, and write that as 1 over 10 with a negative in front of it. Perpendicular slope is positive 2/5. Positive 2 over 1, but we don't really write it like that. We're just going to say 2. And if I have a whole number -1, I can write that as -1 over 1. And when I write that as a negative reciprocal, okay, it just becomes 1 over 1, which is 1. So yeah, the perpendicular slope to -1 is actually 1. Perpendicular slope, -1/2, -4 over 3. Now this is a tricky one. If my given slope is 0, well, that's a flat line, meaning my perpendicular slope is going to be vertical, and that slope is undefined. So that's what I would write there, undefined. So now we're just going to do a couple of simple examples on whether or not the following pairs of lines are parallel, perpendicular, or either. So if they're parallel, they're the same. Perpendicular, they're negative reciprocals. And if they're not either of these, then they're neither. We can even call this intersecting if we want. just plain old intersecting. Okay, so the first one's pretty easy because I can see that the slopes, these two lines are already in the form y equals mx plus b. So here I have m1 is 1/3, I have m2 is negative 1/3, and these are just neither because they're not the same and they're not negative reciprocals. For this one, 2 and negative 1/2, well, these are negative reciprocals. Okay, therefore the lines are perpendicular. Okay, so that's with m1 equals 2 and m2 equals negative 1/2. Okay, now for C, we actually do have to do a little bit of work here. What I need to do is isolate y. So this is going to be x over 4. I've done a couple of steps there, okay, in my head, but I can see that the first slope is 1/4. I'm going to isolate y here. I'm going to get y equals, oh, x over 4 again. Okay, m2 is 1 over 4. So these guys are parallel lines because those two slopes are the same. All right, now for the sort of what we're leading up to. So what I want to do now is talk about section 4, which is a review of determining equations of lines. So first of all, let's write out the three different forms of lines. I'm actually going to start with the standard form, ax plus by plus c equals 0. Then we have the slope-intercept form, which is y equals mx plus b. Okay. So the pros here is these are easy to graph. Okay, because we can see the slope and y-intercept right away. The ax plus by plus c form is good because you have no fractions. And for these ones, it's easy to calculate x and y intercepts. If you remember that, basically when we sub in x equals 0 and y equals 0, these become very easy calculations. Okay, now I really want to spend a bit of time on point-slope form. Y minus y line equals m x minus x line, because I think these are easiest for determining equations of functions, equations of lines, sorry. So I'm going to use it throughout this lesson, okay, and hopefully by the end of it you will come to like it as much as I do. So just to remind you, because I do think you've seen this before, x line, y line represents any point on the line. Okay, is any point that I know is on the line. So let's use it right away, okay? So I want to determine the equations of the following lines, and for each answer I'm going to write it in both mx plus b and standard form. So why on earth would I start with point-slope form? Well, I'm going to show you. Okay, so if I know that this line, if I want my line to have slope 4, and I know that it goes through 6, 3, I know this point is on the line. Okay, so I can actually use y minus y line equals m x minus x line in the following way. Y minus, and now I'm going to put in the y value that's on my line. Okay, and m, my slope is 4, and I'm going to say x minus the x value that I know is on my line. Okay, so that's how I get those 2 points in there. And what's nice is all I have to do now is distribute the 4 and bring the 3 over to the other side. So my equation for the line having slope 4 and hitting the point 6.3 is this guy. So that's my final answer. Now, I can see that my answer here is in y equals mx plus b form. Now I want to put it into ax plus by plus c equals 0 forms, which is actually really easy to do from here. So all I'm going to do is bring the y to the other side and put it in the order of ax plus by plus c equals 0. Okay, so the key here is that there's 0 on one side and also no fractions. And I want to make sure that a is positive. So I start the line with a positive number. Okay, so let's look at the next one. And this one's actually particularly easy if I want to use y equals mx plus b form. So this is probably the only example that I'm going to use y equals mx plus b form, because the information in the question actually gives me the y-intercept and the slope. So I know that my slope is -2, and I know my y-intercept is 4, right? 0, 4. So I know that my b value is 4. So that one was particularly easy. Okay, but let's go on with some that are a bit more difficult. Okay, so here I know 2 points on my line, but I don't have the slope. So I'm going to have to calculate my slope. So I'm going to do y2 minus y1, x2 minus x1, and that's 8 over 4. So I know my slope is 2. Okay, so I'm going to start with y minus y line equals mx minus x line. And I'm going to sub in any one of those points. I'm just going to use the point 1, 1. I'm going to sub in the slope of 2. So I get y equals 2x minus 2 plus 1, y equals 2x minus 1. And again, if we want to put this into standard form, all I have to do is bring the y value to the other side. All right. Let's do another one just like that. So here we go. y2 minus y1. So I flipped the y2s and y1s there. So remember, this one's allowed to be x2, y2, and this one's allowed to be x1, y1. Okay, I'll get the same answer either way. So I get -4, subtract 4, -3. Oh, I made a mistake. -4 minus 2, 4, 10. -4 subtract 2. So I get -3 over -6, so my slope is 1/2. Okay, so I'm going to sub that into y minus y line equals mx minus x line, y minus, and let's put the first one in, y minus 1 equals 1/2 x minus -4. Don't forget the brackets. Okay, so I'm going to get 1/2 x plus 2, so I did a lot in my head there, plus 1 equals 1/2 x plus 3. Okay, now if I want to put this in standard form, so I'm going to bring the y to the other side, but remember, I'm not supposed to have fractions here, so I should multiply everything by 2, okay, to get this. All right, so we've got 2 here. All right, slope. So I've got -5, subtract -5, 2, subtract 7. I'm going to get 0 over -5. Now remember, 0 divided by anything is still 0. And this here tells me that I have a horizontal line. It's a flat line. Okay, and I can see that if I just look at my y values, they are the same. And the equation of this line is going to be y equals y int because it's horizontal. And I know the y int is -5 because it appears in both as the y value of both those points. Okay, last one here. So I have -10 minus 0, -1 subtract -1. So I get -10 over 0. And in this case, m is undefined because the 0 is in the denominator. Okay, so what does that mean for us? That means that we have a vertical line. And I can tell, actually, because both of my points have the same x-intercept. So x equals x int is my equation of the line. So I get y equals, or sorry, x equals -1. All right. So now we're kind of putting it together for the next couple of questions where I have to know a bit about parallel and perpendicular lines. So if I consider the line with this equation, okay, I want to determine the equation of another line, a different line, with the following attributes. So this is L5, so I want my new line to be parallel to L5 and passing through this point. Okay, so parallel to L5, I need to know the slope of line 5. So I can see that the slope here is 1/2. So therefore, my new line, the one that I'm trying to find right now, has slope of 1/2, and it also goes through C for -8. So to figure out the equation of my line, it's y minus y line equals mx minus x line. I know my slope is 1/2, and it goes through the point 4, -8. Oops. X minus 4. And now let's just solve for y. So we get 1/2 x minus 2 minus 8. So we get 1/2 x minus 10. And then it asks me to put it in standard form as well. So I get 0 equals 1/2 x minus y minus 10. But of course we can't have fractions. So I'm going to multiply everything by 2. And this is my answer in standard form. Here we go. So now I want one perpendicular to L5. So if I know that L5 is y equals x over 2 plus 6, and I know L5 has slope of 1/2, well, I know my perpendicular slope is going to be -2. Okay, so my new line has slope of -2, and it passes through the point D7, -12. So let's find our line. So we get y minus -12 equals -2, x minus 7. So we get y equals -2x plus 14 minus 12. Y equals -2x plus 2. And then if I want to write that in standard form, it's going to be 0 equals -2x minus y plus 2. But we always want the a value to be positive. So I'm just going to multiply everything by -1. And there you go. All right. I think we have 2 more here. Yep. Okay, so determine the equation of the line that is parallel to this line and passes through the point A, -5, 8. So firstly, I know that the slope of this line is -2. Therefore, my new line, when I'm trying to find in this question, has a slope of -2, and it goes through the point A, -5, 8. We've got y minus y line equals mx minus x line. So I've got y minus 8 equals -2, x minus -5, y equals -2x minus 10 plus 8, y equals -2x. So our final answer would be y equals -2x minus 2. And of course, in standard form, I'm going to write it like this. No fractions, no negative value multiplying the x. All right, last question. Determine the equation of the line that is perpendicular to this line and passes through B16. So if I look at -3 over 4x minus 1/2, I can see that the slope of this line is -3/4. So the new line is going to have a slope of +4/3 because it's perpendicular, and it's going to go through the point B16. So I need to find a common denominator here so that I can add those two fractions. So this is the equation in the form y equals mx plus b, and then to put it in standard form, I will move the y to the other side. And I'm going to multiply everything by 3 to get rid of the fractions. Alrighty. Okay guys, that's it. So the idea now is that you are going to complete this formative assignment on determining equations and hand it into Google Classroom whenever I have announced the deadline in class. Okay, good luck guys, and as usual, see me if you have any questions.